This video we're going to learn what is back titrations. So the normal titrations that we have is called direct titrations. Comparing to back titrations, that will be quite different. For direct titrations means that we got some chemical that we feel interest, or we're going to analysis the concentrations of these chemicals in the samples. So this chemical normally we'll use it as an analyte and directly react with the titrants. So for examples, we have like a glass cleaner right here. We all know that inside we will have ammonia. So we may, or in process, we dilute it, and then we put it into the conical flask like this. So what we need to do, this is ammonia, is an alkaline, so we use acid, for example, HCl, standard hydrochloric acid, to do the titrations against it. So just right amount of titrants, will be added to the analyte. So once we see the indicator change color, we'll stop the reactions. So in this case, we call this one direct titrations. Normally the chemical in the sample will use it as part of the analyte or titrants, and we carry out the titration. But for back titration, that will be slightly different, because the chemicals inside the samples, some of the sample is insoluble in water. We cannot prepare that as a solution. If it's not in solutions, then we cannot carry out a titrations directly. So for some of the samples, if it's insoluble in water, we cannot prepare it as a solutions. For example, if we want to look into the calcium carbonate inside the seashells, we know that seashells, it is found in sea, so obviously the seashell is insoluble in water. If we want to have a reactions between the calcium carbonate and the acid, actually, I can't have a solution with calcium carbonate in it. So normally what we're going to do, we have 3 steps to do. The first one, we'll dissolve a known mass of sample. For example, the seashells right here, if we have like say for example we have dissolved 10 grams of it, and then we dissolve it into a known excess amount of acid. That means this time I want to put it into acid, and we know the molarity of it, and we also know the volume of it. So we'll know the known excess amount. That means the acid in it will be more than enough to react all the calcium carbonate in the seashells. So what we're doing, we put the seashells in it. So this HCl will then react with the calcium carbonate. The calcium carbonate, because this is a limited reagent, because the acid is used in excess, right? So all the calcium carbonate will react with the HCl, and we may have some unreacted. We'll have some unreacted HCl left behind after the seashells dissolves, or reacted. We may have some unreacted HCl. So these unreacted HCls, we're gonna know how much unreacted HCl left behind. Then next part, we'll titrations. This unreacted acid with, in this case it's acid, so I will use standard NaOH to titrate against it. So we'll have this one, put it as an analyte, and then titrate against the NaOH. So basically the concept is, if we have more, or if we say a lot NaOH have to be required to react with these unreacted HCl. If I have used a large volume NaOH to react, then I know that this one will be a lot as well. If I know that this one is a lot, that means the content inside here will be little, because we remains a lot unreacted HCl. So only a small amount of acid have been reacted with these shells. But on the other case, if this one we just add a few, a very small volume of NaOH to react, then I know that the unreacted will be very little. So if the unreacted is very little, that means most of the HCl have been reacted with these seashells. So I can conclude that these seashells, will have a large amount of calcium carbonate in it. So have a look of a general calculation steps. So how would it look like? Because in this case, we will involve 2 reactions. One will be the seashells with the acid. The other one will be the unreacted acid with the NaOH. So the second part, it will be the titration. The first part, okay, it will be a chemical reactions. Okay, so basically the very first step you have to do, you have to write down these two equations first, because we involve some mole ratio difference right there. So you have to write down the two equations like this, and then you put down the data. Say for example, okay, I will tell you the seashells will be 2 grams, okay, and then excess known amount acid. Say for example, I put 1.2 m and then 0.08 dm cube of HCl to react with this calcium carbonate. This is the known amount of acid that we've prepared. So this one, okay, and then we have the seashells in it. Okay, so this seashells may be 2 grams. This acid, it will be like 1.2 m, and then we have 0.08 dm cube. Okay, so after react, okay, they will have like some solutions, unreacted one here. So unreacted HCl, okay, leaving behind, okay, these reactions, okay, I would use plus HCl and then put bracket here. It represents that some of HCl is unreacted, so this will be unreacted acid. And this acid, it depends on the question. Sometimes we directly titrate these remaining solutions with NaOH. Sometimes we may dilute it first, or sometimes we may just take part of these solutions to titrate. So therefore, different time will be different questions will be different. So it really depends. Okay, the questions. Okay, so just a simplified one. Okay, if I directly titrate this remaining HCl with NaOH, then you will have another results. Okay, this one will be the molarity of NaOH that we have used and the volume. This is the experimental results. So by calculating this number of mole of NaOH, that would be the number of mole of titrants, step 3. Okay, and then by mole ratio, actually I can find out the unreacted acid. Remember, you have to label the acid as unreacted acid so that everyone will be clear what you're calculating. So that will be mole ratio. Find out step 4, unreacted acid. If in the case we didn't do anything changes, okay, for example, we didn't take out part of the volume from the remaining solution. Say for example, this one have 250, I take out 25, then number of mole will be different. If I didn't do anything for that, then this number of mole should be the same as this number of mole. Okay, so number of mole unreacted HCl, and then we're going to calculate the number of mole of added HCl. This HCl, how much have we added? We make use of the molarity and volume here. I know that at the very beginning how much, okay, how many number of mole of HCl we've added in it. So this will be added, this will be unreacted, this unreacted, this unreacted. Okay, so how much acid have been reacted with this calcium carbonate? Okay, it will be the difference between the added minus remaining. That will be unreacted. Okay, I repeat one more time. Okay, remember the number of mole of HCl reacted will be equals to the number of mole of HCl added minus number of mole of HCl remain. Okay, so by doing so, okay, I will know that, okay, how much HCl have been reacted. Okay, and this reacted HCl, by using the mole ratio, I can then find out the mass of calcium carbonate, okay, that really react with the acid. Okay, so we can find out the number of mole of the sample, and then we can proceed to the answer. Okay, so maybe a little bit abstract for the whole thing, so but we practice a few more times, and you'll know that, okay, the steps that we're going to do it. So one example. So right here, okay, we will have the steps. Okay, first step with the balanced two equations. So let's have a look what happened here with marble. We put it into known amount and known volume of HCl. So some of the HCl will be unreacted and remains, and they will titrate with the sodium hydroxide, just like the examples just now we mentioned. So we're going to find out the percentage by mass of calcium carbonate in the marble. That means this 2 grams, it is not reliable. Okay, we'll put bracket for that. Okay, so balance two equation. So the first equation will have calcium carbonate react with HCl, and then they will have calcium carbonate, calcium chloride, CO2, and H2O, and more importantly, you have some HCl left behind. Okay, so this will be the remaining. The second reactions, okay, that will be the HCl reacted with, okay, NaOH. Okay, so that will be the step 1 done. Step 2, we're going to write down the data. Okay, we know that this is 2 grams. Okay, but this is not reliable, so I put bracket for that. Okay, and then HCl will be 1.2 m and then 0.08 dm cube. Okay, that will be the HCl added. Okay, and then the unreacted acid, okay, required. This acid, okay, required 28.8 and 2 m NaOH to have a complete reactions. So that means in the process, okay, no extra steps we have involved. We didn't take part of the solutions out. So this one, okay, will be the same as all the HCl we have used. Okay, so NaOH that we have added, okay, will be 2 m, and then we have 0.0288 dm cube. Okay, so basically, okay, we have finished writing down the data. We first found the number of mole of titrant first. Okay, so second step we have finished. Okay, then third step, number of mole of NaOH, that will be 2 times 0.0288. Okay, so the answer for this one will be 0.0576 mole. Okay, and then number 4, okay, the number of mole of HCl unreacted. Okay, that will be equals to 0.0576 times 1 divided 1. Okay, and it will be 0.0576 mole. Okay, so this one is the step 4. In this case, this step 4 are the same. Okay, and then step 5, okay, we're going to unreacted one. Okay, you see that I said we're unreacted. So now I'm going to calculate HCl added. So HCl added, okay, it will be equals to 1.2 times 0.08. This one, 1.2 times 0.08. So this values, okay, that will be 0.0960 mole. Okay, so step 6, we're going to find out the reacted one. Okay, remember, number of mole of HCl reacted will equals to number of mole of HCl added minus remained. Okay, unreacted. Sorry, we use the same word, unreacted. So therefore here we will know that it will be 0.0960 minus 0.0576. So by doing so, okay, you'll find that the number of mole will be 0.0384 mole. So we are exactly having this amount to react with the calcium carbonate. So by mole ratios, okay, mole ratio, you have 2, you have 1, okay, so we can know the mass. Wait, this is part 6, part 7. Okay, we can find the number of mole of calcium carbonate because we know that 0.0384. Okay, we're going to divide it by 2 times 1 because you're going from HCl to go to calcium carbonate. So by doing this, okay, you will have 0.0192 mole. And then the mass of this, okay, will be equals to 0.0192 times, okay, 40 plus 1 plus 12 plus 16 times 3. And the answer for this part, it will be 1.2 gram. Okay, so after you got 1.2 gram, okay, we're going to find out the percentage by mass. Okay, percentage by mass will then equals to 1.2 over 2, okay, times 100%, and the answers, okay, will be less than 100%. That will be 56%. Okay, that will be the answers. Okay, so this is basically how we're going to do back titrations. Okay, remember it involves 2 equations. Okay, and okay, the remaining HCl you have to label. How can you do the back titration? Well, you have to illustrate. You're calculating the unreacted one, the added one, or the reacted one. Okay, these words are very important to help you to clarify, okay, what you're doing. So normally it will start from the titrations reaction first, find out the HCl remaining, and then you find out the added one minus the remaining, and then you can know the reacted one, the really reacted one. Okay, the reacted HCl. Okay, and then we use this reacted HCl to find out the mole ratios, to find out the number of mole of calcium carbonate. It will be like that. just give you one more example. Okay, so right here we have a N-acid tablets. Okay, we have magnesium hydroxide in it, and then they will first dissolve in nitric acid. You can see known volume and known molarity, and the remaining acid will directly titrate, okay, with the sodium hydroxide, and this is the results. Okay, we're going to find out percentage by mass of magnesium. So the first one, okay, balance equation. So we have magnesium hydroxide together with nitric acid. Okay, nitric acid will be HNO3. Okay, the ratio, so it have to be 1 to 2 because you have 2 OH, you have 1 HCl, so therefore this one have to be multiplied by 2. So the like the other ones, okay, the balancing equation is not very important. You just know that we have some excess HNO3, and this excess HNO3 will be directly added into another part of the experiment, which is reacted with the NaOH. The NaOH we use will be 2m and then 18 cm cube. Okay, and the HNO3 that we have added, okay, that will be 1m and then with 75 cm cube. Okay, and then the mass, okay, that we have used will be 1.2 gram for magnesium hydroxide. So basically the data we have finished writing, and we first find out the titrant one. Okay, so will be the number of mole of NaOH equals to 2 times 0.02 18. Okay, so the answer for this part, okay, it will be 0.036 mole. Okay, and then the HNO3 unreacted one, okay, it will be equals to 0.036 divided by 1 times 1, okay, will be 0.036 mole as well. Okay, that will be step 4, unreacted one. Okay, and then step 5, we're going to find out the added HNO3, so therefore we can do the subtractions. Okay, so we will have number of mole of HNO3 added, okay, that will be equals to 1 times 0.075. Okay, the answer will be 0.075 mole. Okay, and then, okay, that will be the reacted one. Okay, the reacted one. Okay, number of mole of HNO3 reacted will then be equals to the added one. You add 0.075, but you remain 0.036. So the answer for this one, okay, it will be 0.039 mole. Okay, so we'll finish this one. So now we know that is 0.039 mole. Okay, so we know this one is 0.039 mole. Okay, we're going to find out the mole ratios. Okay, so 7, okay, that will be the number of mole of magnesium hydroxide, and then that will be 0.039 divided by 2 times 1, and the answer, it will be 0.0195 mole. Okay, 0.0195, and then the mass of magnesium hydroxide will then equals to 0.0195 times 24 plus 16 plus 1 overall times 2. Okay, so the answer for the mass, it will be 1.14 gram. Okay, finally, okay, you're going to find percentage by mass. Percentage by mass will then be 1.14 over 1.2. Okay, and then times 100%. Again, this is less than 100%. Correct. Okay, the answer for this one will be 94.7%. Okay, so basically back titration is a little bit complicated, okay, but the process more or less it is the same. Okay, so it will be like that. To summarize, okay, these videos, okay, we learned that, okay, back titrations, okay, we will use this when the sample, okay, is insoluble in water. Say for example, we have calcium carbonate in the shell, in the seashell, or you have like magnesium hydroxide in the N-acid. Okay, remember, not anti-acid, okay, in N-acid. So we're going to find out these chemicals, okay, how much are they? Okay, so we'll first, okay, we'll dissolve it into a known mass of samples. So this known mass, this known mass of sample, we're going to dissolve in known excess amount of acid. So this acid will have some unreacted left behind, and we'll do the titration of this unreacted acid, okay, with the NaOH. So back, okay, from the NaOH results, we can find out that unreacted exit, how much we have left behind. So basically all the steps will be like this: 2 equation first, jot down the data, and then we'll start from the number of mole of NaOH. This one, okay, we found the mole ratios of unreacted HCl. Pay attention whether the process, okay, it is same number of mole, or they have extract part of the remaining solutions to carry out the titration. Some of them will be like that. So after we know the unreacted exit, we find out the number of mole of HCl added. Remember these terms I have emphasized so many times. Added, okay, unreacted, okay, and also reacted one. Okay, so reacted will be equals to the added minus unreacted, and again by mole ratio, okay, we can find out the number of mole of calcium carbonate, and then we can find the mass and find the percentage by mass. Okay, so it will be like that. Okay, about the back titrations. Hope you understand what is it. Okay, that's all for this video. Bye bye.